Welcome back to the workshop. We're going to do a little bit of a lesson today. I guess we are going to discuss amps, watts, that kind of thing, electrical issues. This kind of brings me back to a video I did, probably the first one I ever put out, was showing the respect of a vacuum cleaner, how it makes so much noise when it's you plug the hose or whatever and you think it's going to burn the thing up because it's just drawing so much current and whatnot. But I showed in that video that it doesn't do that. When you plug up the inlet of the vacuum cleaner, it actually takes a lot less power, even though it makes a lot more noise. It's kind of like having an employee sitting around, and if he doesn't have anything to do, he's not getting any work done, he screams a lot louder. If you keep him busy, he just kind of stays steady and he's getting something done. And when you're looking at electricity, it's about the same as that. So you have voltage, which is what your normal house current is here. It's 120 volts, what comes out of our walls. And you plug your vacuum cleaner into it. And then your vacuum cleaner, or whatever you're using, will come usually and tell you that it's in how many amps it'll draw. So you want to stay within a certain limit. You know, your 20 amp circuit breaker in a house is going to handle up to approximately 20 amps without blowing or tripping. But voltage also sometimes is concerned as watts, and watts is more of a what kind of workload is getting done. So what we want to look at is as the vacuum cleaner is not getting any work done, the airflow is not going through the vacuum cleaner, it's not really doing anything, it's just sitting there spinning a propeller in there to create a vacuum. So the discussion came up on my other video that, you know, it shows really good when I block the inlet of this, the amperage goes down, which is what we have here, is a clamp-on amp meter. I've made up a little cord so we can get a hold of it. We have a black wire, a green wire, and a white wire. And it doesn't matter which one of those you put this clamp on, the white or the black. The green is the only one that you can't put it on because that is our ground, and you shouldn't have any amperage on that. If you do, you've got some problems. That's a safety wire, and that's not supposed to carry any kind of current unless you have a malfunction. So I've made up this cable so that I can read different amp loads on stuff that I need to know about that plugs into the cord. So we can show on the vacuum cleaner. What I'll do is I'm going to turn the vacuum cleaner on, and you'll see that the amperage on this, I hope I've got it there enough to where you can see it in the camera. I can't tell with my little small screen there, but I can tell you what it's reading. So we're going to turn it on. I'm going to block the inlet of it. Then we're going to turn it off, and we're going to turn it to where I can block the outlet port up on the back side of it. Now the outlet port up here is good, except for there's also other outlets on there. So I cannot block off as much on the outlet as I do the inlet, because this is more geared towards vacuum versus blowing out the backside. And so some of the air does bypass it to keep the motor cool and that kind of thing. But the general principle is the same. If I was able to block it completely off like I can the suction side, the amperage would do the same thing. So what we're going to do is go ahead and start it up, and we'll see how many amps it draws. And this is going to get a little noisy. Hopefully my microphone will pick up over the top of the vacuum. Here we go. Okay, so the initial voltage comes in. That's your inrush. Went up to about 12 amps, which is no big deal. It comes right back down. And right now we are reading about 10.6 amps. So I can go ahead now and close off the inlet. The noise goes up on the vacuum. Sounds kind of bad. But our amps go all the way down to 7.2, 7.1. So we can tell it's not doing any work. It's just kind of sitting there, spinning the propeller in there. We let it back off, and it brings right back up to 10.5 amps, 10.6. So it's doing a lot of work. If I could block it completely off on the outlet, you'd do the same thing. I don't want to do it for long because it is cooling the motor off. But we'll go ahead and block the outlet. And it's going down to about 8.5. So it'll do the same effect. It's how much air flows through the vacuum cleaner is going to determine how many amps, which also generates into how many watts of power you're using. Even your hair dryers, whatever, usually they're not listed in amps, they're listed in watts. And that's really the amount of work that's getting done. Like I say, you can take your voltage times your amps is going to give you how many watts of power you're actually using, or you can do the exact opposite. If you have a 1400 watt hair dryer, say, and you want to find out how many amps it's doing, you take your 1400, divide it by the 120 volts, and that'll give you the amount of amps that you're drawing on it. So that kind of shows you have to have that airflow through there. It's not using near as much power if you're not using it to its full capacity. That's how the current works on something. Pumps would work the same way. Anything that's moving a product like that is going to have your flow is going to determine how many amps it's actually drawing. Unless you're just deadhead or stop it completely and just burn up your motor. I don't recommend that. But anyways, that's the lesson in electricity today. Hopefully that clears up the question that one of my subscribers had, and he can see that it's works both ways. Inlet and outlet will affect the amps. So thanks a bunch for watching. Hope this was informative. Hit the like, the subscribe, and the little bell, and we'll give some more lessons on different things and show you how to fix stuff too. We'll catch you on the next project. Thanks a bunch.